this is Amy. Welcome to my math class. Today we are going to look at graphs of cubic functions. We will first look at the basic graph of the cubic function and then look at the transformational form. Let's get started. Let's recall two functions we learned previously. One is y equals x. Now we know the graph of this function is a straight line which passes through the origin, and the gradient is number 1. And based on the graph, we can get the key feature of the function. Similarly, for y equals x squared, the graph is a parabola and it opens up. And based on the graph, we can get the key features as well and determine the domain and range. Now, question is, for this new function, what will be the graph? And then what will be the key features of this graph? Then similarly, we are going to select some points to get the basic shape of the graph first. For example, we can consider these simple x values. When x equals 0, y is 0. When x is positive, y value will be positive as well. So 2 cubed, we will have 8. And then this one 1 and this one 1 over 8. But when x is negative, y value will be negative because the index is 3. It means 3 negative values multiplied together, then the result will be negative. Therefore, we will have negative 1 over 8, negative 1, and negative 8. After we have finished this table, just plot all these points on the diagram. So 2, 8 represents the point, it's here. And then we are going to connect all these points using the smooth curve. Then we obtained a more accurate graph using the technology. And then we are going to use this diagram to analyze the key features of the cubic function. First, what will be the shape? It is like this from the negative infinity to positive infinity. And we can consider this one as climbing up a hill. And we can see there is a special point at the origin. So this point, it is a flat one, and we call this one as a point of inflection. So this one is different from the parabola. So for parabola, we have the turning point, but this one, it does not turn around because it's from the left, and then it goes up again on the right. So this point is defined as the point of inflection. We will look at the definition a little bit later. Now we just consider this one as a flat point, and you can also consider this one as a resting point. Then we will see the x-intercept and y-intercept. For y-intercept, we just let x equal 0 and the corresponding y is 0. Therefore, y-intercept is 0. Similarly, x-intercept is 0 as well. Here, also pay attention, when x approaches positive infinity, so y goes to positive infinity as well. And then if x becomes very, very small, and then y value goes to negative infinity as well. After we have obtained the basic graph of y equals x cubed, we are going to see the transformational form, how the values of a, h, and k affect the graph. To make it simpler, we just consider the value of a be positive, and we are going to investigate. Therefore, when a changes, the graph is dilated from the x-axis by a units. And also, the size of a increases. For example, we have a equals half, a equals 1, a equals 5. As the size of a increases, the graph becomes steeper. Now, let's look at the effect of h. Therefore, when h is positive, the graph is translated to the right, or we say moved to the right. And when h is negative, the graph moves to the left. Now let's look at the effect of k. Therefore, the k value tells us the vertical translation. If k is positive, the graph moves up. If k is negative, the graph moves down. Now let's conclude. The value of a tells us the dilation from the x-axis. Then the value of h tells us we move the graph to the right or left. And k shows moving up or moving down. And then we are going to conclude the key features of the transformational form. For the shape, it is still climbing up a hill when a is positive. Then the point of inflection, the flat point, will be hk. And the y-intercept just let x equals 0, and for x-intercept we let y equals 0. For example 1, if we are required to sketch these two graphs, assume we have already obtained the basic one, y equals x cubed. Now for the new one, by comparing with the standard form, the value of a is equal to 1. Then the shape will be the climbing up a hill like this. And then this number 2 shows us the graph will be moved to the right by 2 units. The constant -1, it means we will move the graph down by 1 unit. Therefore, the point of inflection will be 2, -1. After that, we're going to calculate the y-intercept. Let x be 0, we will have -2 cubed minus 1 equals -9. And then for x-intercept, let y be 0, and we will have x minus 2 all cubed minus 1. For this, we can get the value of x in this way. So x minus 2 all cubed equals 1, and x value will be number 3. Okay. Then we are going to represent all the items on the diagram. First, see the point of inflection, and then x-intercept, y-intercept, which is -9 here. And then we are going to use these 3 points and the shape to get the graph. So the final result is like this. And we can see the point of inflection has been moved to the right by 2 units and moved down by 1 unit. And then on the diagram, we have to show the y-intercept as well. Therefore, extend the graph to show the y-intercept. Based on this diagram, we will know, so the domain and range, both of them are from -infinity to positive infinity. Let's look at the exercise that we are going to focus on ADFG. Now we mainly focus on the shape and the point of inflection. For the first one, y equals x plus 2 all cubed, then minus 1. For this, we are going to rearrange it to show it as x minus -2. Now we will see the value of h is -2. It means the graph will be moved to the left by 2 units and then moved down by 1 unit. Therefore, the point of inflection will be -2, -1. As the coefficient of x cubed is number 1, the shape will be like this, climbing up a hill. For question D, this tells us h value is 2. We move the graph to the right by 2 units, and then +5 shows that we're going to move the graph up by 5 units. Therefore, the turning point will be 2, 5. And similarly, the coefficient of x cubed will be 1, then the graph will still be like this, climbing up a hill shape. For f, the coefficient of x cubed is number 2, and it is positive, but 2 tells us the graph will be dilated from the x-axis by 2 units. The graph will be a little bit deeper. And then h value is 0, k value is 3. It means we are going to move the graph up by 3 units. Then the point of inflection will be 0, 3. For this question, we are going to divide both sides by 3. Then the coefficient is 1/3, and the shape will still be climbing up the hill 1. And h is 0, k is negative. It means we are going to move the graph down, so the point of inflection is like this. Now let's see, if we have the negative coefficient of x cubed, what will be the graph? In this case, for the same value of x, the y value will be opposite. For example, if we have 1, 1 on the original graph, and then for the same x value, we will have 1, -1 on the new graph. It means the point is reflected in the x-axis. For every point, we can reflect it to get a new graph. Therefore, the new graph will be like this. Then we can see for the new graph, the shape is climbing down a hill. Therefore, we can obtain the new graph by reflecting the original one in the x-axis. And the graph shows the feature of climbing down a hill. Now let's conclude. For y equals ax cubed, the value of a, if it is positive, then the basic shape is climbing up a hill. If a is negative, then the shape will be like this. We call it climbing down a hill. Now let's look at exercise 2. First, for part A, for this equation, we are going to reorganize it. Put x cubed to front, and then the constant is 3. And for this, the basic shape is determined by the coefficient of x cubed, which is negative. Then it means the basic graph should be climbing down a hill. And then the point of inflection is 0, 3. Because h is 0 and k is 3, it means it has been moved up by 3 units. For question B, the coefficient of x in the brackets is not positive. Therefore, we have to rearrange it. Now we put x to front, and then we will have this expression, and then distribute cubed to negative sign. The result will be negative than x minus 3 cubed. For this one, the coefficient of x is negative. Their basic shape should be climbing down a hill. H is 3, therefore the point of inflection will be 3, 0, because k is 0. Now for part C, we have the expression the coefficient of x cubed is negative 2. Then the basic graph will be climbing down a hill. And the equation has been reorganized. We can see h value is -1. It means graph has been moved to the left by 1 unit. And k is 1, and move up by 1 unit. Therefore, the point of inflection is -1, +1. Now let's look at part D. The coefficient of x cubed is a half, which is positive. It means the basic graph should be climbing up a hill. And then 3, it means the graph will be moved to the right by 3 units, and 2, positive, and then move up by 2 units. Therefore, the point of inflection is 3, 2. In order to sketch the graph, we still need to calculate the y-intercept and x-intercept for each function. I will just leave this part to you. Now let's conclude. Today we mainly focus on the graphs of cubic functions in this form, and then the coefficient of x cubed, positive or negative, will determine the basic shape. And then no matter which shape, there will be only one x-intercept. The domain and range will both be the interval from -infinity to +infinity. That's all for today's content. Thank you very much for watching. I will see you next time. Bye.